Do you see how fine that pattern is? Now we can take a look at the balls. Well, I might as well do this review the right way and tear this thing completely apart. Today I'm going to be unboxing the Tronxy CRUX 1. It has a similar form factor as the Ender 2 Pro, and I really liked that printer. So let's unbox this thing and see if it's any good. Up top here we have a little bit of sample filament, all the tools you'll need. Oh, and look at this, we got a nice little upgrade right off the bat. This is a textured PEI spring steel sheet. We've got the top section of the printer right here, and the bottom section here. It looks like this entire build only uses one fastener size, and overall, one of the big advantages of these small form factor printers is how easy they are to put together. So altogether there's 5 screws to secure this arm here, and they give you this nice screwdriver type hex drive, which makes this thing even easier to put together. The spool holder bolts onto the side, just like so, and then I attach the handle up top. With that handle installed, it's nice and easy to pick this thing up and move it around. It feels a little bit heavier than the Ender 2 Pro due to its all-metal construction. You have to peel this sticker off and put it on yourself. And we can put our PEI sheet on. And that's a nice strong magnet that they're using. This thing even comes with a filament runout detection switch, which is a nice touch. I'm just going to plug the printer in over here. And the only bit of wiring that I have to do is I have to plug in this Z-axis stepper motor. And I think we're good to turn this machine on. Wow, this thing is super quiet. There's no fans that spin up when the machine turns on, so that's always something that I really like in a printer. You've got a nice selection of different options for loading parts onto this printer. It comes with this little USB reader with a micro SD card installed onto it. So first thing I'm going to do is I'm going to run my bed leveling. Alright, so I'm just going to tap each point that I want to go to. We'll start with the center point. Now I'm going to level all 4 corners of the bed. And this print surface is pretty flat to begin with, so I didn't have to make much adjustments to it. It seems like I have a slight bow in this bed, so it's a little bit higher in the center than on the sides. But overall I think I've got it close enough, and that was nice and fast. This printer makes a lot of beeping noises when it's doing its homing procedure, so let's see if I can go into the system settings. Yeah, I can turn the sounds off, so now it's not going to beep at me. Now when I go to home the machine, it just homes without making all those beeping noises. Overall, this firmware is nice and responsive, and when I give it multiple commands, it just queues them up and does them all without crashing. So I think Tronxy have done a good job with their touchscreen firmware. So we're ready to print. I'm going to go in this folder, and I'll print some test models. Okay, I've spent a couple days printing with this machine, but first I want to go over the upgrades that I installed, starting with this fan duct. This is the original fan duct. I didn't really like it because it blows the air more downwards and to the left instead of blowing it where it needs to go. So I have a new design here that you just install in its place, and it just gives you much better airflow. This original fan duct isn't very well designed, so it was pretty easy to come up with something that performs better. This thin metal handle kind of hurt my hand when I was picking this up and carrying it around. So with these handle pieces, you can just kind of snap them in place, and then that gives you more surface area for when you pick this thing up. And this makes it a lot more comfortable to move this machine around. Despite its compactness, this machine is pretty heavy, so having something to spread out the weight on these handles is really nice for me. Then the last thing that I printed out was this little spool holder cover. When I was working on this machine, I was looking at something and I kind of bonked myself in the head. It's kind of a hazard, especially if you're carrying this thing around. It could poke or catch on something. So having a little cover for this makes it a little bit safer. It's also a bright color so you won't bump into it accidentally. And it just adds a nice little accent color here. You can find all three of these upgrades on my Patreon page where you can download them and print them out. Aside from those three small upgrades, this machine is completely stock. On the table right now I've got the Tronxy CRUX and I've also got the Ender 2 Pro. I've got both of these on the table together because I want to compare and contrast the features. These printers may be similar in size, but there's a ton of differences on their features. The Tronxy CRUX 1 starts at $179. That's about the same price as the Ender 2 Pro. Right now Creality is selling it for $140. I think I picked this one up for about $110. So you can find some pretty steep discounts on the Ender 2 Pro. If we look at the print volume of both of these machines, the Ender 2 Pro has a 165 by 165 by 180 print volume, but the Tronxy CRUX has it beat with a 180 by 180 by 180 build volume. So you've got a slightly bigger build surface here, and add to that, this machine comes with a nice spring steel PEI sheet. The Ender 2 Pro comes with this kind of flimsy refrigerator magnet type sheet. One of these spring steel sheets will set you back about $20 that you have to pay on top of the price of this machine. If we look at the overall size, weight, and portability of these machines, the Tronxy CRUX is a little bit heavier. It weighs about 6 kilograms compared to the Ender 2 Pro's 4.7 kilograms. So the Ender 2 Pro is quite a bit lighter, and it comes with a nicer handle that's easier to carry. Despite the Ender 2 Pro being a lighter machine, I would give the Tronxy CRUX the edge in portability because it's just so compact and narrow. The Ender 2 Pro's footprint is a little bit bigger in every dimension. You can see it's about 2 inches taller. This screen sticks out to the left quite a ways, and this tensioning knob sticks out to the right. All of that adds up to this being a pretty wide printer. If you look at the side profile, it's no contest. The Ender 2 Pro is over a foot wide. Compare that to the Tronxy CRUX, which cleverly hides away the stepper motor and the tensioning mechanism into the base of the machine, which results in a much narrower printer front to back. I kind of like the drawer on the Ender 2 Pro, but it's a feature that I can live without, and if you're carrying a 3D printer around with you, it shouldn't be too difficult for you to also have a small toolkit or tool bag. One of the reasons the Ender 2 Pro is so much lighter is because it's mostly made out of plastic and aluminum. Compare that to the Tronxy CRUX, it's mostly made out of steel and aluminum, and overall it seems like a much better built machine. The Ender 2 Pro is pretty well built, but there's a lot of plastic parts in the base, which I'm a little bit concerned about being a fire hazard. If we look at the electronics and wiring on both of these machines, the Tronxy CRUX is clearly superior. When you turn on the Ender 2 Pro, two extremely loud fans kick on. One is in the base of the machine, and one is on the hot end here. Compare that to the Tronxy CRUX, which is on right now, but you'd never know it because it's making no noise. All you have to do is tap the touchscreen and it wakes up, and then you can start your print jobs. So here you can see we've got a nice touchscreen. It's super responsive and easy to use. If we look at the Ender 2 Pro, we've got the old school dial and knob setup. And this screen was extremely bright. Whenever I was filming it, it was completely washed out because of how bright it was. While people that have used 3D printers for a long time will be very familiar and comfortable with this display, I think it's something that can be off-putting to new users because you've just got to push this button, turn the knob, and know how to navigate all the menus. Compare that to the Tronxy CRUX, which has a simple touchscreen with all of the features that you need. Overall, I think this will be a much better printer for beginners simply due to the interface. We've got a lot of really good options for I/O on the Tronxy CRUX. You can plug in a micro SD card here, and they even give you a little diagram that tells you how to line up the SD card. Just kind of hold it like this, just like on the picture, and then plug it in. But you'd be surprised the number of times I try to plug in one of these micro SD cards upside down. So just having this little graphic that reminds you that you need to have the pin side up when you plug it in is really handy. Also, if you want to plug in a USB drive, you can see they've got the two little holes on the USB drive, so you know it's backwards if you don't see the holes there. See, you've got the little holes like this, and you can plug it in just like that. Those are just some really quick and easy guides to help you not plug things in backwards, which at the end of the day makes this machine just a little bit easier to use. And finally, if you want to do USB over serial to print using Octoprint or Clipper or whatever, you've got a really nice beefy USB port to plug into. Compare that to the I/O on the Ender 2 Pro. You've got this little notch that you can barely tell is a spot where you need to plug in your SD card, and you kind of push it in and it's completely recessed into the machine, so you don't know if you've got an SD card there. You just kind of get in there with your fingernail to push it to get it out. This isn't very user-friendly. Also, you've got no options for plugging in a USB drive like this. And if you want to do USB over serial, you've just got this tiny little micro USB port there. These connectors are really small and intended for mobile devices. So in my opinion, they're not really the right choice for a 3D printer. I much prefer the larger USB port. This one, you have a pretty good chance of breaking the connector off in that port. So overall, the Ender 2 Pro has inferior I/O. When it comes to mainboards, I think the Tronxy clearly has the better mainboard compared to the Ender 2 Pro. I modified this Ender 2 Pro and found there was a lot of really annoying stuff in here. They're using a different connector for the stepper motor wiring. That's just an annoying thing that's going to get in the way of you modifying your printer. It's pretty much an industry standard to use a 4-pin JST connector for your stepper motor driver outputs. But for some reason, Creality decided they wanted to reinvent the wheel and go with something completely different. The Tronxy CRUX, on the other hand, it's got a really nice upgradable motherboard with all the standard type of ports and connections on there, so it should be really easy to plug new parts into it. Also, I really like how this is all in a metal housing in the bottom, so if any of the electronics fail, you don't have to worry about it catching on fire. On the Ender 2 Pro, everything's plastic, and I'm not sure how fire resistant the plastic that they used for this case is. When the Tronxy CRUX was running, I touched all the stepper motors and they were all pretty cool to the touch even after hours of printing. Versus on the Ender 2 Pro, I had my stepper motor back here running very hot. It felt like it was over 60 degrees Celsius. It would burn me if I touched it for too long. To make things worse, this stepper motor is mounted to a plastic bracket, and between this super hot stepper motor and this plastic bracket, I'd be worried about this melting if I was doing a long extended print, maybe at elevated temperatures. And I'd be especially worried about it if I was printing inside of an enclosure. But you've got a different story when it comes to the Tronxy CRUX. All of the stepper motors are held in place with steel brackets, so you don't have to worry about it getting too hot and potentially melting those. When it comes to fan selection, the Tronxy CRUX is a clear winner. I don't know why Creality doesn't step up their fan game, but I'm really not a fan of the fans that they're using. I've upgraded this to some really nice fans. I've got a Noctua fan here and a 5015 blower. On the Tronxy CRUX, this comes stock with a 5015 blower fan, which provides excellent part cooling. And I don't mind the fans that they used on the hot end and the base of the printer because they're completely silent when you're not running the machine. And when you are running the machine, I didn't notice them being particularly loud. This Ender 2 Pro sounds like you're firing up a jet engine when you turn it on, and that's probably my least favorite thing about this machine. If we look at the heated bed on these two machines, aside from the bed being larger on the Tronxy CRUX, resulting in a larger print volume, it also has a thicker aluminum sheet. This appears to be about 4 millimeters thick, and the sheet on the Ender 2 Pro is only about 3 millimeters thick. So the Tronxy CRUX should have a more even temperature distribution than the Ender 2 Pro. Also, on the topic of the heated bed, on the Tronxy CRUX, all of the adjustment knobs stick out on the sides here, so it's really easy to adjust bed leveling. On the Ender 2 Pro, all the knobs are like hidden underneath the printer and they're really small. So you have to like pull it all the way out to the end here so you can reach them. Otherwise you just kind of have to stuff your hands in here and try and rotate the knobs. On the Tronxy CRUX you have this collective adjustment knob. This adjusts the offset of the Z-axis limit switch. So instead of having to turn all 4 of the knobs in equal amount to move the bed up or down, you can just adjust this, which makes bed leveling a lot easier. Also, on the topic of bed leveling, you've got a really nice built-in guide here. We've got this touch screen with all of these buttons. So I just have to push the button for the leveling point that I want the printer to go to, and it just moves there. I can get my piece of paper out and adjust this knob. It's super simple. On the Ender 2 Pro, there's no such bed leveling assistant, so you have to home the printer and then manually move the print head around by frickin' spinning this wheel over and over again. I think leveling a bed is the least fun part of 3D printing, so having a really poor implementation of bed leveling I think really hurts this machine in terms of its usability. If we look under here, you can see there's the Y-axis stepper motor that moves the bed forwards and backwards. I really like how it's tucked away in here instead of hanging out the back like on the Ender 2 Pro. A properly designed and maintained belt system shouldn't need to be adjusted very often, if at all. So I don't mind that it doesn't have a knob off the front where you can adjust things easily. In fact, I find that these adjustment knobs are more trouble than it's worth. because it's really easy to bump these and ruin your belt tension. Versus on a machine like this, it's pretty much set it and forget it. Another nice touch on the Tronxy CRUX is that they've supported the lead screw on the top and bottom. Compare that to the Ender 2 Pro. On the bottom it's roughly the same, but on the top up here you can see there's no support for the lead screw and it can move around a little bit. I'm not sure if this has a practical effect on quality, but it just seems a little bit nicer on the Tronxy CRUX that this lead screw can't be bent or moved around as easily. The other nice thing about this metal base is it's a structural part of the printer, but it also really helps with heat dissipation. This metal frame doesn't hold in heat nearly as much as this plastic frame. So the plastic frame on the Ender 2 Pro might be one of the reasons why they have to install a really loud and annoying fan into the base of the machine. So in broad terms, I'd say that the Tronxy CRUX is easier to use, has much better build quality. I mean, just look at this on the Ender 2 Pro, it's just wobbly. There's a lot of stuff that I don't like about the way the Ender 2 Pro is built. This Tronxy CRUX, on the other hand, is built like a tank. It's really nice and sturdy, it's got a really solid feel to it, and it's really easy to use. Now it sounds like I'm really just shit-talking the Ender 2 Pro in comparison to this Tronxy CRUX. But the Tronxy CRUX isn't a perfect machine either. When it comes to print quality, I actually prefer the prints that I got off of the stock Ender 2 Pro. It comes with a Boron setup. Right now it's direct drive, but this is a whole upgrade series that I've been working on. This thing's got an absolute beast of an extruder hot end combo on it right now, but the stock setup is actually really good as well. I was able to get excellent print quality off of the Ender 2 Pro without doing any modifications. It's loud, difficult to use, harder to assemble, has questionable build quality, but overall this thing printed like a champ. The Tronxy CRUX also printed quite well, but I just noticed that the quality was a little bit nicer on the Ender 2 Pro. The biggest differences on the actual motion system of these two machines are the use of metal rails here compared to the typical V-groove wheel setup on the Ender 2 Pro. You can see they use V-groove wheels for the Z-axis on this Tronxy CRUX, but on the X and Y axes they use these metal wheels. And those ride on these steel rods that are pressed into an aluminum extrusion. It's a very simple and elegant solution, and it should be very low maintenance, but I noticed that it produced some artifacts in the print itself. You'll notice some really deep vertical lines on this part of the print. This was the first print that I did on this machine, and these deep lines were kind of a temporary issue. Basically the belt was way too loose on this printer, but I quickly noticed that and fixed it. I just tightened up the belt and this deep pattern went away. The interesting thing about those artifacts is they had the exact same pitch as these belts. You can see that for every tooth of the belt there's a ridge in the print. However, if you look a little bit higher, you can still see that there's a repeating pattern there. And it was a little bit trickier to figure out where that pattern was coming from. You can also see it here. Do you see how fine that pattern is? And you'll notice that it cuts through the layers perfectly. These walls were printed with a Y-axis move. So as the Y-axis moved, you can see it's generating this ridged pattern. On the X-axis, you can see a similar pattern. I was trying to decide if it was coming from the belt or the stepper motors, or, and this is what I really think it was, the bearings themselves. I think if you were to open up one of these bearings, you would see that the number of balls inside of there and the spacing between those balls would match up exactly with this pattern that I was seeing. At least that's my suspicion. I think the pattern has to be coming from the stepper motor or from those bearings. And I'll go over my reasons for why I think it's from the bearings. But if you look on this bunny print, you can see it's kind of got this watery texture. Like the reflections aren't perfect. They're kind of distorted in this weird way where it kind of looks like the rough surface of water. And I think you can still see that pattern on this bunny print. They have these vertical lines that are cutting through the print. Very strange. When you're making diagonal lines, they kind of show up as well. So it's very curious. I think what's happening is we've got some pattern being induced by these metal wheels and the bearings here. So let's take a close look at these wheels that they're using. Typical V-groove wheels are made out of Delrin, which is a hard and slick plastic. These wheels, on the other hand, are just pure steel bearings that ride on these metal rails. A couple things to note about these wheels is, you see I can just pull it off the end here. That's one of the really convenient features about them. But the other thing is, there's quite a bit of tension on these wheels. With the Delrin wheels, you don't want to over-tighten them, otherwise you'll squish the Delrin and you'll develop flat spots. But on these, they tighten them down so that it's just like a steel clamping action that holds this thing in place. And it holds it in place very well. This should require less maintenance because you're just tightening down steel parts versus Delrin wheels, which have to be adjusted every couple hundred hours on your 3D printers. If you're using them a lot, that can be very annoying. And they're tricky to set up in the first place because you have to be experienced in setting the correct tension level. However, with these metal wheels, you can pretty much tension them at the factory and you just slide them on, and it's a system that you just set it and forget it. But one of the downsides of having these metal-on-metal contacts is there's no plastic or rubber parts to absorb any of the small vibrations that are created by bearings. If you move this really slow, you can feel kind of a grittiness, which I attribute to the bearings themselves. The bearings have little balls in them, and as they're rolling around, they're just not perfect and they're causing these little bumps. I mean, this is exceptionally smooth and it feels like it's a really good system, but I can definitely feel some kind of like high frequency vibration going on. So what's going on here? To me, it feels like each ball inside of this ball bearing is passing individually, and it's causing a little bit of tension, and then you're popping over to the next ball. So you've got this repeating bumpiness from each ball that's passing by. And this isn't cogging from the stepper motor over the belt because I've completely detached this belt. So this vibration that I'm feeling has to be coming from these little wheels. But it's almost like a stepper motor. You can see it advances a little bit with each bump. And I think it's the exact same frequency that I'm seeing in these lines on the 3D print. These lines are really only apparent on these super glossy prints that show surface texture extremely well. If you look at this matte filament that I printed with, you'll have a hard time picking up the pattern, but if you look close enough, you'll see it's there. You can kind of see those little ridges there, even on this matte filament. You can see that repeated, ridgy pattern of vertical lines on this print. I can see it on all the walls if I look hard enough. But matte filament does a really good job of covering it up in general. But it's still there, so that's something that kind of bugs me, and I wanted to get to the bottom of it. I'm not 100% sure what kind of bearings are used inside of these wheels, but I think it's probably pretty similar to just two of these smaller bearings side by side. I don't want to take these bearings apart because they're part of the machine and they're useful for having a working 3D printer, but I happen to have a couple thousand small bearings of various sizes in my closet, so I got some of those, and I'm going to take these apart and measure the spacing between the balls on the inside to see if that can provide any insight to what's going on here. If you want to take apart small bearings like this, they've got a little circular spring inside of there that's holding on to these metal shields. So you'll want to take out that spring. Oh, that was pretty easy. Alright, now that this spring clip has been removed, oh no, I don't know where it went. I can just kind of get this shield out of there. There we go. Alright, now we can see the individual balls inside of this thing. I'm going to remove the shield from the other side as well. Alright, and then I'll take out that shield. Maybe I can poke it out from this side. There we go. Okay, so we've removed both the shields on this ball bearing. Now we can take a look at the balls. These aren't the highest quality ball bearings. You can see light through them, so these shields aren't doing a great job of shielding things. It'd be pretty easy for dust or water to get inside of these. Now, if you don't have the skill or patience to open up one of these ball bearings, but you still want to see what's on the inside, you can always just close your eyes, squeeze, and hope for the best. Or if you prefer, you can use the polar bear method. If we get back to the bearing that I didn't completely mangle, in order to take this apart without breaking anything, you're going to need to remove the cage. The ball cage holds each ball in the correct position so that the bearing is always supported, but you can just kind of poke it out and it'll release the balls. Here's the ball cage. You can see it's got little retaining features for each of the individual balls and holds them at the correct spacing. Even without the ball cage retaining these in the correct location, you can kind of see they're still spaced out evenly. But if you push all the balls over to one side of the ring, you can remove everything and take it apart. Pretty cool, huh? So you can see this ball bearing has 1, 2, 3, 4, 5, 6, 7 balls. This other ball bearing has room for 8 balls. So the number of balls varies from bearing to bearing, but they all have roughly the same construction, where they've got an inner race, an outer race, balls, and a cage which ensures the balls have the right spacing. A bearing is considered a shielded bearing if it has these metal shields. Also, these balls are greased to reduce rolling friction and wear inside of the ball bearings. The inner and outer race have a semicircular channel that the balls roll around in. In high-end bearings, these are ground to be extremely precise, and they may even be polished to get the best surface finish and reduced friction. This is what you'd call a sealed bearing. It's similar to a shielded bearing, but it also has a rubber seal which will keep the grease in and water out. These are more useful in harsh applications, but for just a regular 3D printer, all you really need is some shielding to keep debris out of the bearings. Bearings that have no protection, as in no shields or seals, are very easy to contaminate and they'll get super gritty. And usually you'll only want to use those inside of a gearbox that's a controlled environment with no debris in it. So I've removed the balls and put them onto this 3D print so you can see the pattern lined up with the balls. This pattern is roughly the same size as the balls. I'd say it's on a similar order of magnitude, but there's nothing conclusive here telling me that these patterns are related to the balls. It's tempting to think that a ball bearing is just a perfect wheel that rotates, but if you move it fast, you'll hear some high-frequency vibrations. It makes some noise, so that tells you that there's something going on other than perfect, smooth, rolling action. Also, if you move ball bearings very slow under heavy load, you'll feel what can only be described as a surface roughness. Even if you're rolling it on an extremely smooth surface, you'll feel some roughness. Even if I roll it on this wood, which kind of gives a little bit as I roll over it, I can still feel a similar surface roughness. And if we repeat this experiment on cardboard, which doesn't have the same stranded internal structure that wood has, which could be blamed for this gritty feeling, even on the cardboard, I kind of feel the same kind of gritty motion. When I'm just playing with these bearings, they feel incredibly smooth, but under heavy load, you'll notice there's something going on inside of them that's shifting around. Also with these bearings, if you hold the outside race stationary and move the inside race, you can see it barely moves. Honestly, I can't tell if this is moving or not, so bearings are built extremely precisely, so if there is any variation, it's very small. If things are moving relative to each other, it should be easier to see on this larger bearing. If my hypothesis about this being caused by bearings is correct, then you should see this same pattern showing up on all wheeled printers, including the ones that use Delrin V-groove wheels. But at higher speeds, those soft Delrin wheels should absorb some of these vibrations. So if your printer's moving with any significant speed, the plastic in those wheels will kind of damp out those vibrations. I've ordered some high-quality bearings, and I'm going to follow this up with some deeper analysis on this topic, because I think that this might explain some of the quality differences that you see between wheeled printers, whether they're using these steel wheels or the Delrin V-groove wheels, and linear railed printers, which have a dramatically different bearing construction. Instead of having a rotary joint, they have a linear joint where the balls are automatically fed to the front of the bearing and you've got like this continuous rolling surface. It's pretty cool. Anyways, the point of that rant was I noticed some strange repeating patterns in the prints on the Tronxy CRUX that weren't apparent on the Ender 2 Pro. So despite the Tronxy CRUX having better build quality, the Ender 2 Pro still ekes out the win on print quality, because the prints that I was getting off this machine just looked fantastic. Most people would have a hard time noticing these really small patterns, but I take a really close look at the printers that I get in for review, and if I notice anything strange, I really zoom in on it and try and figure out what's going on. Well, I might as well do this review the right way and tear this thing completely apart. So I've removed the bed, and you can see it's got this 4-wheel setup. I'm going to take all 4 of these wheels off so that we have the bed completely disassembled. They're using nice strong springs here. After removing the bed, you can see we've got some nice insulation here, some pretty good strain relief. They've tied this cable into this bolt here, so if I pull on this, it's pulling on that zip tie and not on the actual electrical connections. This is Tronxy's version of an eccentric nut. You can see the larger screw in the middle isn't perfectly centered, so I assume what you do is you loosen these Allen keys and then you can rotate this to get the tension set correctly. However, since there's no plastic or rubber components to wear down on this drivetrain, I think this is kind of a system where you just set it and forget it and you never have to adjust the tension on these. So if you're having issues, you might need to mess around with this, but I would advise you to just leave it alone for the most part. And one place that they could have reduced some weight on this machine is this steel base. If they made this out of aluminum instead, you could reduce the weight quite a bit. And that goes for the rest of this machine. It comes in at over 1 kilogram heavier than the Ender 2 Pro, so their use of steel for everything definitely adds some weight. It also adds rigidity and strength and reduces costs of manufacturing, but I think I'd rather have this machine be a little bit lighter. If you changed all of these panels from steel to aluminum, you could probably reduce the weight of this machine about 1 kilogram, so it'd be about the same weight as the Ender 2 Pro. That would make this machine feel a lot lighter and more portable, which is a feature that I would appreciate. You can see this base is also made out of steel. Let's get into the base of this machine so we can take a peek at the power supply and motherboard. With all 6 screws removed, this bottom piece just comes right off. So let's see what we're working with here. We've got a power supply. Wow. The switch for adjusting the voltage is recessed inside of the power supply. So you have to stick a screwdriver or something in there to flip that switch. That's not a very good solution. You can see they've actually cut away some of the power supply's housing. Mine came set to the correct setting as far as I know, so it wasn't an issue. If you look at the wiring in here, it's pretty well done. Right here, they're not using crimped ferrule ends. I always like to see crimped ferrule ends because that's just like a standard quality thing that I like to see. I suppose these wires could catch on fire, these terminal blocks. Looks like we've got a nice board here. It says it's Tronxy branded. It looks like this fan is held in place with only 1 screw, but all the components around it are kind of holding it in the right place. So I don't mind that. There's nothing really to get caught in this fan, and it's just providing broad cooling over this whole motherboard. Looks like we've got a pretty big chip here. I'm not sure what that is. It says GD32F427. We've got kind of an interesting plug here. It says it's got 24 volts, 5 volts, ground, and PWM. So this is some kind of multi-use port here. There's heat sinks on all of these components. It's got a buzzer built into it, so that's what was making the noise. When you home the machine, it likes to beep a lot. Oh, and one really cool thing about it is the screen is on the back side of this board. So everything is really efficiently packaged in here. I'm not going to take it apart to the point where I see the board, but it looks like we've got a little connector down here, a little ribbon connector that goes around to the other side and hooks up to that screen. It looks like down here we've got a spot for an additional stepper driver and a plug for another stepper motor. So this is the E2 motor. So if you wanted to add an extra stepper motor to this machine and you're savvy with doing surface mount component soldering, you could add that to this board. Then you'd have to reprogram everything, so it would be a lot of work. But overall, I like what I see here. This is some pretty neat wiring. We've got a really good cooling solution. Looks like right here we've got a 1 farad 5.5 volt capacitor. That is quite a beefy capacitor. I'm not sure what that's for. It could be for some kind of power loss recovery feature. They've put heat sinks on all of the major components, except for this chip, which has a lot of surface area, so it's probably fine. Overall, it looks like a neat job down here, and they've got a lot of good features on the main board. I'm going to try replacing this stepper motor to see if that resolves some of the strange ringing artifacts that I'm getting on this printer. To remove this stepper motor, I'm just going to undo these 3 screws right here. It looks like they're using a press fit gear. I just happen to have a 20-wheel pulley and a stepper motor just laying around in my garage, so I was able to put this together pretty easily. This is the old stepper motor, and this is the new one. I'm hoping everything will fit down there. But one of the things that I'm noticing is the cogging on this stepper motor is really strong, and I'm wondering if that's what's causing those vertical lines through my prints. This one is a lot smoother, so I'm hoping it'll just run a lot smoother. I think this is the hot end wires. So the hot end wires are kind of tucked away in here underneath the fan. I think that's just kind of an interesting spot for them. But they also don't have crimped ferrule ends. I think I've got to practice what I preach here and just go through and add crimped ferrule ends to all of this stuff. There's no reason it shouldn't have them, so I'm going to put them on. Something that I'm noticing here is they used high-strand silicone wire for the main power connections, but on the heated bed, which is a cable that flexes a lot, they're using a more standard type of cable that isn't super flexible. You can see if I bend it, it holds onto the kink. So this is a medium strand count wire. Ideally, I'd like to see this made out of a silicone wire, because over repeated bend cycles, these wires can break down. Everything going to the hot end is made out of thin flexible wire, so I don't see there being any issues there. It's just the heated bed cables that I'd really like to see switched with some silicone wiring. Alright, I've got crimped ferrule ends installed on all of the terminal connections, and now I'm going to put the stepper motor in place. We've got our new stepper motor installed. Now I'm just going to put the rest of this back together. When you're sliding this back and forth, you can't really feel any bumpiness, but if you try to push this around slowly, you'll notice there's quite a bit of friction that gives, and it just kind of doesn't move around super nicely when you're trying to push it around slowly. So we'll see if this new stepper motor helps. I honestly don't think it'll help very much. It is a lot smoother than the stepper motor that I took out of there, but there's a little bit of weirdness in this drivetrain due to these metal bearing wheels. I'm going to put the microphone onto this Y-axis carriage, and I just want you to listen to it. I've also got an accelerometer app on my phone, so it can I can just stick my phone onto the surface here, and then moving it back and forth, I can record the vibrations. So this thing will pick up any vibrations that are occurring. And I'm just going to let this settle out. Now I'm going to just slowly move the printer. And there's a ton of vibrations from moving this thing. I'm just trying to steadily move it forwards and backwards, and it's constantly accelerating back and forth as I'm sliding it forwards. So there's quite a bit of cogging that's inherent to this linear rail system. You can see in X there's a significant amount of vibration. Now let me just toss it. So I'm just trying to steadily move it forwards and backwards. And you can see that amount of noise. Alright, now I've got my microphone attached to this carriage. This is an aluminum base, which is a lot lighter than the heavy steel one on the Tronxy CRUX. But I'm going to just attach it to a bolt here. Alright, now we're going to do the same tests with the Ender 2 Pro. Now when I try to gently roll this backwards, I'm not getting a huge amount of vibrations here. You can see I'm just like moving it forwards and backwards. For these small motions, these Delrin wheels actually have a lot less vibration. Also, I've got the microphone attached to the carriage, just as I did before, and as I move it back and forth, you can hear the noise is a little more muted I'm not sure how to get more scientific about it. Alright, now our belt is all tightened up. And let's just run a test print with that new stepper motor. I know a lot of you in the comments section like to think that you're smarter than me, so I'm just doing this to set the record straight, because I know a lot of you in the comments section will be like, "Oh, it was the belt the whole time. Oh no, it was the stepper motor. You're so dumb." Well, we'll see who's dumb when I turn this on and do another test print. Uh-oh. Shit. The stepper motor is wired backwards. I'm going to have to switch that stepper motor around. For some reason, the 3D printer industry still hasn't standardized how to wire up their stepper motors. We got some that are wired one way and some that are wired the other way. Some of them just spin backwards. So you got to flip some wires around. First I'm going to turn the machine off. All I need to do is unplug this Y stepper motor. And that should have reversed the direction of the stepper motor. Oh no. Okay, let's do some more wire swapping. Every time I put all the screws back into the bottom panel, I regret it every time. So here goes. Gotta undo those screws again. Alright, I'm gonna switch the last two wires. So I'll switch the two outer wires around now. Alright, I'm not bolting that shut again until I know it's working. Let's turn this on. There we go. Okay, so I just had to flip all of the wires around. So flip all the ones from the left to the right, just basically mirror all the connections, and that changes the direction of the stepper motor. With this bed leveling assistant, it's actually really fast to go through this whole procedure, so I actually don't mind it. Just touch each corner and then adjust each knob. Pretty simple. And then just check the center for, I don't know, a sanity check. It's really easy to do bed leveling on this printer because it's got that wizard that moves the print head to the right point for doing the bed leveling. It's a super convenient feature, and it's one that I wish all 3D printers would have. Alright, so we're printing along. We've got a couple layers laid down, and I can already see the pattern showing up. So let me just pull this off the print bed. So as you can see here, the same pattern is there. It just exists no matter what I want to do. I might not have even noticed the issue if they shipped this printer with some matte filament, but on these glossy filaments I can definitely see these vertical lines showing up in virtually everything that I print. So overall, I think this is a great machine. You've got great build quality, very easy to use, tons of great features, but in the end it's slightly let down by this print quality issue that I'm having. I don't know if there's a way to get rid of this, but I'm going to look into it. I might try replacing these bearings with something else. And to be clear, I've seen texture like this on a lot of other printers that I've used, but it's just more pronounced on this one. So at the end of the day, would I still recommend this printer? I think I would. I'll probably keep using it because it's proven to be a quite reliable printer, and it takes up virtually no space. One thing that I've been running out of lately is space to store all these 3D printers. So having a nice small one that I can set up, do a print job, and put it away is super convenient. And I printed out about 10 of these little fan duct designs, and I had no issues, even with pretty steep overhangs, thanks to the excellent part cooling and great build surface. So overall, I still really like this machine. If you want the absolute highest level of print quality, you might have to look elsewhere. But for what it is, this machine is very excellent in terms of its ease of use, build quality, and the reliability at which it's producing these prints for me. Also, I'll be getting a Rat Rig V Minion in soon, so heck yes, that's going to be super cool. That's probably one of the best small cantilever printers out there on the market, so it'll be awesome to review that thing. It'll also be my first printer that has linear rails. Alright, well, thanks for watching this episode of Nathan Builds Robots. Hope you enjoyed it. And if you have any questions or comments about anything that I talked about in this video, I'd love to hear about it in the comments section. But yeah, I'm not a big fan of the wire that they chose for the bed, just because it's going to be bending a lot, and that's not a super flexible wire type. They have pretty nice cable management, so the bend here isn't extreme, but over repeated bend cycles, I expect that kind of standard wire to fray over time. And eventually it might get hot and start smoking and all that fun stuff. So again, I'd really like to see silicone wires used in those applications or some other type of fine stranded wire.